it doesn't mean that the thing that you read 990,000 tokens ago is like front and center in the LLM's attention, and it will 100% get that right? Like if you said the way to access my database is blah, 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 and then gave it 900,000 extra tokens, it might not pay much attention to that special instruction that you gave it. And so even though it says a million contexts, it doesn't mean, it's not like a binary thing. You still want to keep your context small if possible.
Yeah, that's a really important point. There's interesting work being done with long context and on two fronts. One is performance. Typically, most autoregressive transformers, which is the technical term for next token predictors that are popular right now, like everything from GPT to Claude to Gemini, they have what's called a KV cache that scales quadratically. And that is just a way of saying that the longer your context grows, the square of that is needed for memory and for processing. It takes a lot of processing to deal with a long context. I shared a martial arts themed video at the end of the year talking about some new US open LLMs. And one common theme among a couple of them was this hybrid architecture for Mamba and Mamba transformers, where you've got a linear scaling for a bunch of this. And you can deal with longer context from a performance perspective in a better way. But regardless of performance, which is something that we want to be able to load large code bases and large documents and have it work well and have it work quickly and have it work cheaply, there's this thing called context rot. And that is, people have noticed that models tend to start to suck. They just don't work as well. They get confused, they make things up, they omit things, and it just seems like they're being overloaded, kind of like humans, especially me. When you've got like too much going on, it's easy to forget something. So it's not ideal. I've noticed when I was using some models through OpenRouter that if I blew past their context window because they chose a provider that had a smaller window than the one that I wanted, it would say, this is not going to work unless you enable middle out compression. Now, middle out compression is a joke from a series called Silicon Valley, but they actually named their thing middle out compression in OpenRouter because it literally takes the middle out, because they say that the best things in the context are usually like the start of the context and the end of the context. And those are the things that LLMs are best at remembering anyway. So if you're going to do less destructive compacting, they figure they kind of just take the middle out. Now, obviously, that's not very sophisticated. That's not going to help you to capture and maintain useful information there. So this is an interesting area of research, and we're kind of digressing into a tangent, but it's relevant, is how do we manage context? And the theme here is markdown context engineering. How do we engineer context so that we are efficient and lean, but we don't have too much information loss? And a big part of that is understanding what is necessary across iterations or across instances, and how can we distill the important things and discard the less important things. So you definitely hit the nail on the head there of like, this is a key principle here, is how do we manage context so that we can get the most bang for the buck, get the most information dense, but small length context.
And that makes a ton of sense. And you don't want to anthropomorphize these too much, but it does. It tracks with human experience, right? I've been studying David Allen's productivity, the get things done approach, and the main idea of that is the more stuff you have kind of churning in your brain, right? If I'm working on something, but I think, okay, I gotta make that doctor's appointment for that kid, and I gotta do this, and I gotta follow up with this, and it's all kind of churning in your head. And his idea is you get it out of your head, put it somewhere else, so that way when you go to work, you have the thing that you are focusing on, and you know that everything else you have a system of dealing with some other way. And so that would be, in human terms, it would be, I know that I trust my to-do list. And then in model terms, it'd be okay, a future iteration of Ralph is going to hit that task. I don't need to think about that task. I'm thinking about this task.
Yeah. So, that is one common principle between these two things is with skills, you can just load the skill that you need for what you're doing now. And, with Ralph as a paradigm, you just need to do the task that you're working on now. You're working on one thing at a time, and it is much easier to manage than trying to take on the world. So Ralph is an external bash loop that feeds information to a...
Did you like that clip? Well, check out the full episode. Leonardo and I put Open PROSE through its paces. We check out Ralph Wiggum and the Ralph loop, all sorts of great discussion related to AI coding, different models, different agents, different harnesses. Check out, the link is in the description. Also, please join our Discord community. We've got great content, great discussions, and subscribe to our channel if you haven't already.